Okay, so today we're going to talk about the init method and the keyword self in Python. Okay, so let's quickly review what we talked about in last week's video, class methods. So when you call a method off a class, for example, in the image, you can see that we're calling example.add and passing in the parameters 1, 2. This works exactly like a function. So the add method works basically like an add function, except now the add method is associated with a class, example. And you basically call it by using the dot between the class name and the method name. So example dot add. If we had another method like subtract, we would have called it example dot subtract. And this is how you call class methods. However, this isn't actually dealing with objects. Right now, all we're dealing with is a class. But an object is what's known as an instance of a class. So basically, a class is like a guide to creating an object. You could have multiple objects from the same class. In order to create an instance of the class, what you have to do is you have to specify the parentheses after you call after you write the class name. So in the second example, you can see, or in the second image, you can see the example. Example equals example followed by parentheses. Whereas in the first one, we only use example dot. We don't use the parentheses after. The example with the parentheses after makes this example variable an object instead of just the result of the method call. So example is known as an instance of the example class, this variable right here. However, you may think, okay, then what happens if we call example.add instead of calling it off the class, which is capital E, example? What happens if we try to call it off the object? Well, you may be surprised to know that this won't actually work. You may look at this and be like, wait, but add has 2 parameters, and we're passing in the 2 parameters. Add example, clearly the variable example, is related to the example class. And although all of this is true, Python does something slightly different when dealing with classes versus objects. And it's important to note this distinction so that we can know when to use which. All right, so the first thing we need to understand is the init method. It's a special method in Python, as with most methods which have double underscores before and after their name. The init method is a special method. And what this init method does is it's a special method that is run whenever an object is created. So if you remember, when we called example with the parentheses after, Python in the end will call the init method. It'll call it behind the scenes. You don't have to explicitly call it because Python will call it. All right, so it calls the init method, and the init method declaration is like this: def underscore init self. So the init method takes one parameter called self. However, if you notice, example doesn't have any parameters. Remember that example actually basically is just a call to init. But this doesn't have any parameters, so why does this work? Well, whenever you deal with object or methods related to an object, the first parameter, typically called self, is always implicit. So Python itself will pass the self keyword. And also, you note that in the first image, we don't actually specify an init method, and it still works. We're still allowed to call example followed by parentheses. The reason that's the case is that Python automatically inserts an init method if you don't specify it yourself. So it's totally optional to include it. However, if you do include it, you can add more functionality to the actual code inside the method body, and therefore can have a little bit more customization if you need it. So the first parameter in the init method is called self, and it's good to note that this is convention to call it self. So it's not necessary. I could have called this any legal variable name. I could have called it X. I could have called it ABC, whatever, and it still would have worked. But it's typically convention to name itself. Okay, so now let's talk about differentiating between object methods and class methods. So the first visual distinction we can make is that methods that are called off an object or an instance will always have an implicit parameter called self. Once again, it's just convention to call it self, but it's good practice. So if you look at the two pictures, the first picture, we have an add function, which has the self keyword. It has the self keyword as the first parameter, and then it has two parameters, num1 and num2. And then we just return the sum of num1 and num2, quite expected. But here we call myExample equals example, so that's how we create an object. So therefore, the variable myExample is an object or an instance of the example class. And then we call myExample.add 1, 2. But you may look at this and be like, okay, I have two parameters or two arguments in the .add call. I pass in 1 and 2. However, the method itself defines 3. It defines self, num1, and num2. So what about self? What's included with that? Well, what's important to note is that Python automatically inserts the first parameter when calling off an object. So the self is actually implied to be the example, the myExample object. So you don't have to pass in any instance for self, but instead Python will do that automatically. And the actual issue is if you do pass in something for self, you'll actually fail. It won't work as expected, as you can see in the second example. Here we have num1 and num2 as the two parameters for this add function in the second image. And here we do the exact same thing. We call myExample.add1, 2. So the only difference between these two images is that the first add method has self as the first parameter, while the second has no self. It has simply the two parameters. So what happens if we were to try to call 1, 2? You may think, okay, the 1 goes to num1 and the 2 goes to num2. Well, that's not the case. If you remember, Python will always assign the first parameter when calling off an object. It'll assign the first parameter to be the object, the instance. So instead of self, it assumes this num1 to be self. And then it'll pass in this to num1, and 1 will actually be passed to num2. And 2, well, there's no third parameter. So that's why Python throws an error. It says expected 2 parameters, but 3 were provided. And the third one, the implicit one, being the parameter. So if instead we change this to example.add, so calling it off the class, example.add, well then this would work, because when calling it off the class, Python does not pass in the self keyword or pass in the object into the function. But when you do call it off an object, well, as you can see in this first example, Python will implicitly pass in the first argument. Alright, so that's the difference between object methods and class methods. And it's a very key distinction. It's a very subtle one. You need to know that Python will provide an implicit parameter. And if you forget about that, you will get an error. Okay, so let's quickly summarize what we've talked about. So the first thing we talked about was calling a method off a class, which was a review of what we did last week. If you call a method off a class, and if you remember to do that, you use the class name, then the dot, and then the name of the method you're trying to call. If you call the method off the class, it works exactly like a normal function. The parameters are passed in one by one. So the first argument is going to be passed to the first parameter, and so on. However, if you use a method off of an object, or if you call the init method by calling example parentheses, or the name of the class followed by parentheses, Python will always implicitly provide the first self parameter. And so it's important that you actually specify that in your method declaration. The reason Python does this, I'm not too sure about, but it's just how the developers chose to do it. Okay, so now we've talked about functions, but let's talk about attributes, also analogous to variables. So just like with class methods, class attributes are tied to the class. So you can call So in this case, num1 and num2 are two class attributes. They're basically variables, but instead of being defined at the global scope, they're defined at the scope of a class. So basically indented at one level. And you can actually access these two variables now the same way you access a function. So with a function, you specify the parentheses after the name of the function. But with attributes or variables, you don't. So you still do the example dot num1 to access num1, which holds the value of 10, and example dot num2, which will access 12. So this is how you access class attributes. But then we could talk about accessing object attributes off of objects. So basically instance attributes. So let's print. The first thing we want to establish is that self is in fact an instance of example. And to do that, we can use the special type function, which you should have learned in intro. The special type function will just convert, or will just print out or return the type of this class. So if self is an instance of example, print type should print example or something along those lines. And in fact, it does. If you were to run this bit of code, you'd see that type of self is in fact example. So we've established that self, or the first implied parameter, will always be the type of the class. And that's the same for these functions, like an add. Okay, so unlike with instance variables, or unlike with class variables where we defined it at the same level as all other functions, instance variables or instance attributes are actually defined within the init method. So you could do self.num1 equals num1. So remember that self is actually an instance of example, but it's an object. It's not the class itself, it's an object of the class. So doing self.num1 will try to access the num1 variable associated with the self object. But since none exists at this point, since num1 doesn't exist at the point, Python will just create it. So basically, if it doesn't exist, Python will create it, which works with any other variable. But then you see, okay, I have a num1 here and a num1 here. How does Python know which one's the difference? Well, the important thing is the identifier. This num1 has no identifier, so by default, it uses the parameter num1. But this num1 does have an identifier, and that identifier is self.num1. And so therefore, this left side refers to the instance variable, while the right side refers to the parameter. And similarly for the second one. But now how do we access these variables? Well, in order to access them, you actually have to, you can only call them within special or instance methods, because you have to actually call them off of self. And remember that self is only passed in automatically when you call it off an object, like you can see here, my example dot add. So def add, you pass in self, which is an implicit parameter. Notice how add, we don't actually specify any parameters, but because my example is an object, it passes self automatically. And then we could call self.num1, which would actually be equal to 5, since we passed in 5 as the first parameter into init. And self.num2, which is also 5, this parameter. And so num1 plus num2 would return 10, and therefore this would print out 10. So this is how you create an instance variable. It differs, it's a bit different than class methods, but the general concept is the same in how they work. So now we'll take a closer look at some code. So here we have the init method. The init method has self. It has two parameters, n1 and n2. These parameters correspond to the arguments passed in when calling this constructor, example, followed by the parentheses. So 5 and 10 correspond to n1 and n2 respectively. Self, if you remember, was implicitly passed in because we're dealing with example. Okay. Then we have the second method, example.add. Remember how my example is in fact an object because we define it by calling the constructor. So my example.add will actually print out self.num1 plus self.num2. And well, what is that? Well, self.num1, clearly we defined it as being equal to n1, which was the argument 5. And self.num2 is equal to n2, which was the argument 10. So this is why 5 plus 10 is equal to 15. In the second example, it works exactly the same way. My example, this actually should be my example 2. If we called my example, this would still print out 15. But if we print out my example 2.add, assume there was the letter 2 here, my example 2.add, it would use self.num1 from example 2, which would be 15, and negative 5, which would be 15 plus negative 5, which is 10. So my example 2.add would print out 10. So that's why these two work. And remember, self does not need to be passed in because it's implicitly provided. Then we have the self method or the add method, which works exactly like a function, except for the fact that self is implicitly provided. But apart from that, most methods just work exactly the same way as a function. And this is how this is why this program provides the output specified. So then you may be wondering, when would you want to use a class attribute versus an instance attribute? For most purposes, a class attribute seems to be working a bit easier compared to instance attributes. So why would we ever want to use an instance attribute? And this also correlates to methods. The reason is that class attributes are actually tied to the class, quite obviously, and instance attributes are tied to an instance. And the important thing to note is that you can only ever have one instance of, you can only ever have one class, but you can have multiple instances of the same class. The thing with class attributes is that they're shared among all instances. So there's only ever one copy of a class attribute. But an instance attribute is different for each object. So object 1 could have its own set of instance attributes. Object 2 would have its own set of instance attributes. And therefore, if you ever have an object that needs its own information, that information that shouldn't be shared across all the objects of that class, then it would need to be an instance attribute, and you would have to use instance methods. Otherwise, if it doesn't matter, it should remain consistent, then you can use the class attribute. And this is an example. If you have a car class, each specific car would have its own model, its own color. It would have a ton of other features that are unique to it. And those would be examples of instance attributes, because those aren't supposed to be shared among instances. But all cars will have 4 wheels. All cars have headlights. They have braking systems, etc. Right? So in those cases, those attributes would be class attributes because they're tied to the car class in general, not to each attribute. So this is basically a rule, which is what we've covered, what we covered today, or what we covered in this slide. And then we have a couple of exercises. The first exercise is to create a person class, which we had started discussing last week. We want to create a person class which stores their full name, address, and age. And basically, you want a method that can tell them if they're an adult, a teen, or a child. And it's important that you have to use logic, so like if statements, as well as using these variables, for example, age. You can always add more attributes and methods if you want to test yourself, but this is the base. The second exercise is to create a triangle class which has 3 side lengths, and you want to create a method that calculates the perimeter. Then you want to create a second method that checks if the triangle is either equilateral, isosceles, or scalene. And the rules for that is an equilateral triangle. A triangle is equilateral if all 3 sides are equal. A triangle is isosceles if at least 2 sides are equal. And a triangle is scalene if neither of the 3 sides are equal to each other. And that's the 2 exercises we have. If you want to practice, you can add more challenges to yourself to test yourself. But that is it for this, the third presentation. This is once again for the intermediate Python course for Codivate. we highly recommend you to join our Discord if you haven't already, so that you can contact your tutors a lot quicker, and so that you don't miss any notifications that we are posting. All right, but if you've completed all those exercises, I'll see you next week.